Okay, so what I'd like to do now is go through the entire unit circle, labeling degrees, our angles in both degrees and radians, and then going around and labeling the points around the unit circle that are significant. So again, remember how to convert from degrees to radians, because we're going to label things both ways. So for example, if I have 30 degrees and I want to convert to radians, I'm going to multiply by pi over 180. So this is going to be, let's see, 30 goes into 180 6 times, right? So this is the same as pi over 6. So 30 degrees is equal to pi over 6 radians. Just get that highlighted there. Okay, so 30 degrees is the same as pi over 6 radians. And that's what I meant. We're going to label them both. And I think it's nice if you can really memorize your 30, your 45 degrees, and your 60 degrees. So you know that 45 degrees, again, if I multiply by pi over 180, is going to give me pi over 4. And then 60 degrees is the same as pi over 3 radians. Again, using that same conversion. But it's nice to be able to remember those three quickly off the top of your head. So first thing I want to do is let's just go around the unit circle and label these angles of importance. So if we start here on the x-axis, again, this is going to be at 0 degrees, which is also 0 radians. And then just think again in numerical order. First we would come to 30 degrees, then to 45, and then to 60. And again, remember, these were those special angles that came right off of those two triangles that we talked about in the last video. In radians, again, this is pi over 6, pi over 4, and pi over 3. The next quadrantal angle we come to is 90 degrees, which again is pi over 2 radians. And then let's tackle quadrant 2. So I'm going to jump down here. I know that this is 180 degrees, and that is pi radians. All right, so the easiest way to look at this is basically to take into account what we call the reference angle. The reference angle is always made with the x-axis. So if I look at this as my next angle, I'm going to identify the reference angle is right here. Again, it's the angle that's made with the terminal side of that angle, or really I'm going to name it as this angle, but I'm going to use the reference angle, which again in this case is 30 degrees, to figure it out. So again, I know all the way to the axis is 180 degrees, so 180 minus 30 gives me 150 degrees. So now 150 degrees, I could go through the conversion, but it's really easier to just think about this in terms of radians. I know all the way to here is pi radians, and I know that the reference, this angle, is pi over 6 radians. So think of pi with a denominator of 6. I'm going to think of this as 6 pi over 6. So 6 pi over 6 minus pi over 6 is just 5 pi over 6. My next angle would have a reference angle of 45 degrees, or pi over 4. So again, this will be 180 minus 45, which is 135. And if I want to think in terms of radians, again, the reference angle is pi over 4. So think of pi with a denominator of 4. 4 pi over 4 minus pi over 4 would leave me with 3 pi over 4. And if I do the same thing here, now my reference angle is 60 degrees. So 180 minus 60 is 120. And again, that reference angle in radians is pi over 3. So 3 pi over 3 take away pi over 3 would leave me with 2 pi over 3. So now let's jump down and use that same logic in quadrant 3. This time, to identify each of these angles, I'm going to add the reference angle. So for example, to identify this first one, this will be my reference angle. Again, the reference angle is made with the x-axis. So really, the angle would go all the way to here. The initial side is always the positive x-axis. My reference angle, again, is 30 degrees. So my degree measure here will be 180 plus 30 degrees, which is 210. And again, now thinking in radians, this again is a 30-degree reference angle, or pi over 6 radians. So think of this angle, your pi radians, as 6 pi over 6. And then add pi over 6, which would give me 7 pi over 6. Likewise, I'm going to add 45 degrees to 180, which gives me 225. And then add pi over 4 to 4 pi over 4, which gives me 5 pi over 4. Adding 60 degrees to 180 would give me 240, and adding pi over 3 to 3 pi over 3 would give me 4 pi over 3. We next get to that quadrantal angle, which is 270, or 3 pi over 2. And now to come up with the next 3 angles, again, I'm going to subtract, but I'm going to subtract from, remember, I can think of this angle as 0 degrees or 360 degrees. And in radians, that would be 2 pi. So I'm going to subtract from 2 pi. Again, my reference angle is always made with the x-axis. So again, this is my 30-degree reference angle. So to come up with that degree value, we will subtract 30 degrees from 360. So 360 minus 30 degrees is 330 degrees. And to come up with the radian value, I'm going to subtract pi over 6 from 2 pi. So think of 2 pi with a denominator of 6. So that would be 12 pi over 6. So 12 pi over 6 minus pi over 6 would give me 11 pi over 6. To jump to the next one, we'll go to, again, we're going to subtract 45 degrees. So that would give me 315 degrees. And then subtract pi over 4 from 2 pi. So I'm going to think of 2 pi as 8 pi over 4. So minus pi over 4 is 7 pi over 4. And then for the last one, we'll subtract 60 degrees from 360, which gives me 300. Or subtract pi over 3 from 2 pi, which will give me 5 pi over 3. All right, so that gives me all of the special angles that I need around the unit circle. And now to fill in those ordered pairs, again, I can think about what we discussed in the previous video. Remember, we already looked at sine of 30 or sine of pi over 6. I know that that is 1/2, which gives me this coordinate. And cosine of 30 degrees, or pi over 6, is the square root of 3 over 2. So now using symmetry, I know what this ordered pair would have to be. Again, just using symmetry, I know that this would be negative square root of 3 over 2, 1/2. Using the same symmetry, I can go to the next angle with a 30-degree or pi over 6 reference angle. So this point, excuse me, would also be negative square root of 3 over 2, and this time we would go down negative 1/2. Same thing, using symmetry. Using symmetry on the other side, this point would be positive square root of 3 over 2, negative 1/2. So what this does is it tells me what the sine, cosine, tangent, or any of the reciprocal functions are of these specific angles. And again, we can go through this now for the other points. So for example, if we're looking at this 7 pi over 6, I know that sine of 7 pi over 6 is negative 1/2. Cosine of 7 pi over 6 is negative square root of 3 over 2. Tangent of 7 pi over 6 would be sine over cosine, or negative 1/2 divided by negative square root of 3 over 2. So this would give me a positive value, a negative over a negative, after I cancel the 2's. So tangent of 7 pi over 6 would be 1 over the square root of 3. And again, I could find any of the reciprocal functions the same way. So I'm going to pause this video, or actually stop this video, and then I'm going to go ahead and send you a completed version of the unit circle. But I'd like you to fill this out, finish filling this out, and then you can check yourself with the finished copy that I sent you. But I think it's important to be able to identify these trig values of using these angles around the unit circle. I'll continue on one more video where we'll kind of put it all together and make sure that you feel comfortable finding trig values given these special angles.